Hi guys, this is the tutorial for Econ101 Handout 3. I'm Xinran. Today we are going to learn a very useful skill, how to calculate probabilities with using our programming language. We are using a dataset about the physical appearance and occupation to explore some interesting economic questions. So by the end of this handout, you should be able to use the ggplot function and the table function, and you will know how to calculate the probabilities. Some are conditional probabilities. And also, you can determine whether these two events are independent or not. But be careful that this handout 3 only for practice, okay? You can follow this video and practice handout 3 and then try to solve the questions in lab 3 assignments. So if you have any questions regarding your assignments, do not hesitate to ask our TA. Okay, you can email us or just go to the lab session. We are very happy to help you with it. Okay, so now let's go to the setup block. If you can look at this, the shadow area is the coding area. So you can just click this green triangle to run this code, okay? So now we can look at this one by one. So in this block, it's using library Tidyverse, library Woodridge, which means that you are using these two packages, okay? The first package contains some tools that can visualizing and data uh, manipulation that can help you with the following tasks. And the second package contains the dataset we'll use today. And what is the data we are going to use? Is the dataset called beauty. Okay. So now let's look at the following. So as we can see, you may think this is pretty complex, but actually it's not. So let's look at this. We are using this data set, right? And this data set, actually, there are 19 variables, but actually we are only interested in two variables named looks cat and job cat. So let's look at this. So this is the original data set because I already opened it before I running the code. So let's try to do it again to find the data set that you are going to have. So now you can see these two variables, right? Looks cat and job cat. So in this looks cat variable, actually there are only three descriptions of it: above average, average, and below average. So how can we get that? Because as you can see, except these two variables, all other variables about the numerical, right? So what we do it is that so the original data set, there's a variable called looks. It contains five values, 1, 2, 3, 4, 5. And we define the value 1 and 2 below average, which means the rate of looks is only 1 and 2, 1 or 2, okay? And when looks equals to 3, we think this is average. So we named it average. So when looks is 5 or 4, we name it to above average. So when we go back to the data set, we changed. Let's guess what is the original value that we have. So definitely the average is 3, right? And so you can go to, when you compare, let's just look at the first row, right? In the first row, the looks equals to 4. So according to our definition, when looks equals to 4, it will be above average, right? And the second one, the looks is 3, so it would be average, right? So let's look at if this is correct, if we are correctly running our code. So above average and average. So this looks cat is based on the value of looks. Okay, same logic. When service equals to 1, we rename it to service. When service equals to 0, we name it not service. So we we are also look at the first two rules, right? The first one's service is 1, right? So according to our definition, we should change it to service for the description. And the second one's service is 0, so it not service. So let's look at if this is correct, right? Service, not service. So the first block is just changing the looks from numbers to descriptions. The service from numbers to descriptions. And that's it. So the rest part is just converting the variable to factor. Okay. So now we can go to the bar plots. So we can know that now our data is ready. So let's visualize it to get a feel for it. The first chart, that if you can run it, you will get this result. So let's look at what we can get from this. The x-axis is about the job cat, right? Remember, job cat only contains two values, not service and service. And the count is counting that if the people are in the group of not service, how many people are above average and how many people are average and how many are below average. So let's look at this. If we can see that not service case and this yellow one means above average, so we can say that the above average people in not service is about 255 or 4. It's like this, right? And also the green one is the count for average. So this chart is giving us the counts, okay? And how about we want to know the proportion? For example, we can see that totally not service is larger than service, right? Because there are many people in our data set, a large proportion of people in our data set are in not service. So the next chart is doing the thing that gives you a proportion of it. So let's look at this. So now the largest number for the proportion in not service and service is also 1, right? It's just calculate, okay, what proportion of people below average in not service. Okay. So now we can see if you want to compare this code for the proportion and this code for the simply count the numbers, the only difference is the proposition field. Okay. So it changed the y-axis from count to proportion. Now we can clearly see that the proportion of people with above average and the below average is higher than the service section compared to other jobs. Okay. So this chart can give us some first little sight. But actually, why we need the contingency table? We know that the visualization are great, but to calculate the exact probabilities, we need the precise numbers. For that, we use the contingency tables. So for example, we can from this chart know that people not in service and above average is about 254, but we don't know the exact number. That's why we cannot calculate the exact probability. Okay, so the contingency table is helping us with this. So this table's code is here. This function, table function, can create a contingency table between looks cat and job cat, and these two variables are in the data set named beauty, right? And this one, it means you just named this contingency table to looks job TBL. Okay, so the first looks cat automatically be the rows, right? And the job cat automatically be the columns. So if you want to change it, let's try to change it to see if any changes, okay? Okay, now we can see that the job becomes the row and the beauty, the looks become the column. So it's very important for you guys to identify which variable you are going to use to be your column, which variable you are going to use to be your rows. Okay, so let's go back to our correct code. So now we need to know, after getting the contingency table, what we can pull the numbers we want from our table. And the table's name we already gave it. So firstly, what is the value in above average row and service column? So it means that above average and service column. Okay, so you are going to find this number, right? And you name it to above and service total. So it is pulled from the table looks job TBL, and you are using the section above average and service. Okay, so let's give us a little bit change. How about I just change it to average? And what's your answer for this one? It means we are going to look at people are on average and service. So average and service. So the value should be 184, right? So if we run it, 184, right? But let's go to our correct code, okay? And run it again. Oh, above average. Okay, so 114. So now we know how to get the sales value from this. And sometimes we need to know the sum up for one row, one column of one row, right? So let's look at this one. We need to know, if we want to sum multiple values in a table, we need to use the sum function. For example, we can use sum of the values in a row, okay? So if you are going to sum up all the values above average, you can just using this one, right? So let's look at what's the difference between this code and this code. In this code, you are extracting the value from the table, right? But not using the sum function because you are just looking at the value in a cell, right? You are not summing up some values. So the difference between these two codes is about the sum function, okay? So also if you change this above average to average, you are summing up this row, right? You are summing up the average row, but now you are summing up the above average row, and you name it to total above. So this value's name is total above, and this value's name is total above and service. So it's easy to understand, right? So now you can also sum up a value in a column, right? So look at this. Also, you are using the sum up function. But now, did you see any difference between this code and this code? Actually, yes, right? You can see that after having the name of the row, you leave blank in the second part. But now, because you are summing up the column, so the row part is a blank and the column part is service. So be careful about the order, right? If you are summing up in a row, then the second part is blank, and if you are summing up in a column, the first part is blank. Okay. So also same logic. If you want to add up all the values in the table, you are using sum up function and just leave the table's name. Okay, so this value called total n. Total n means you are summing up these 6 numbers. Okay, so now we are getting several values. First one, the total number, and second, the total people in service, and total number in above average, and the number above and service. Okay, so next step, we are ready to calculate the probabilities. Okay, so when you look at this block, this code, so it asking you if a people is above average and in the service case, what is the probability? Okay, so it means that above average and service, you are using this one value to divide the total number, right? So remember what's the name of this value? It means total, above, and service, right? Here. And to divide it by n. So this code is easy because you are just using these two values, total above and service, equals to 114, and total n equals to 1660, right? 260, okay? So you name it to probability above and service. So this is the probability. And how about the probability above average? So same logic, you know this should be divided by n, and you know you are using the above average number to be the numerator, right? Remember what's the above average value? It's called total above, right? Here, total above. So you are summing up this rule, okay? And then you can get the probability here. So this one also, what's the probability that someone works in service? It means total service divided by total n. And how about the above average or service? It here gives you the formula, so you can just use this formula to calculate this probability. But remember that because there's an overlap section. So after adding up the probability above and the probability service, you need to subtract the above and service. Okay, so you can follow this formula to get this probability. And now we can calculate our conditional probability above and service to above. So this one is easy because you can, according to this this description, this formula to get your result. But now how to test this is independent or not. According to the rule, if the probability conditional on average equals to the probability of service, then they are independent. So you can just compare these two are equal or not. So first, you state the probability of service, and then you state the probability service and above. So if actually there are, maybe you are confused about it, so let's make it a little bit change. So remember the probability, if the probability is not if they are equal, despite if it above average or not above average, then they are independent. So actually there's not it using another rule that if PA equals PA, then they are independent. So this is not very precise of it. Okay. So if you are going to use this one, it's okay. If you are going to follow this one, it's also okay. Okay. I suggest you to follow this logic because this is stated by professor. So if these two values are not equal, then they are not independent. But remember, in your lab 3 assignment, you need to give your description rather than just give me the false or true, okay? So you need to give me your reason to tell if they are independent or not, okay? So now you can try to calculate, or you can try to finish lab 3. If you have any questions, you can ask me or ask your TA.